Alright, so in this video we're going to go over number 2, which you had the chance of starting in the last, or practicing in the last video. And so we're actually talking about how to apply acid-base chemistry to solving some problems. And so in this structure we see one functional group that stands out, which is this amine right here. And it's not an aromatic amine, if you thought it was. The reason is it's not directly attached to the aromatic ring, so it's actually just an aliphatic amine, which has a pKa of around 8 to 10, but in this case the pKa is given as 6.4. And so we're going to start off by writing out our general equation. pH equals pKa plus log of base over acid, or the way I presented it in the last video, which is pH minus pKa equals log of base over acid. And now we're going to rewrite it, knowing that we're starting off with an unionized base form with this aliphatic amine. And so I'm going to rewrite this once more as pH minus pKa equals log of UB over the IA form. So again, this is the final equation we're going to use. And the reason why we care about the variation of the equation is if you start with a UB versus starting with a UA, this part of the equation is going to have the ionized either in the numerator or the denominator. So it does change your ratio. So you don't want to skip this step. It really does matter. Yes, we know that it's always going to be base over acid, but we need to determine, are we starting with a UB or are we starting with a UA? Because if we're starting with a UB, then this is the equation that we use, the start equation. But if you're starting with a UA, then we would actually use log IB over UA. So if you notice, the ionized part is now in the numerator rather than in the denominator. So your answer will be completely flipped if you don't do this step. So it actually is important. All right, so what's our pH? Our pH is given in the problem, if you remember, 7.4. It's given up here in the problem. And then the pKa is also given as 6.4. And then we have log of UB over IA. Okay, so I'm going to continue this. So 7.4 minus 6.4 is going to be 1. So 1 equals log of UB over IA. So actually, I have 1 equals log of, and at this point I drop the B and the A because what I really care about is where is the unionized and where is the ionized. So it's unionized over ionized. And then I know that my base is 10, so I'm going to do log base 10. So I'm going to do 10 to the first power, because there's a 1 right here, is equal to unionized over ionized. So in other words, I know that 10 over 1 is equal to unionized over ionized. So to get my percent ionized, so in this case my ratio is 10 to 1, unionized to ionized. To get my percent ionized, I'm going to put my ionized on the top. So ionized is actually the 1 because 10 to 1 is unionized to ionized. So my ionized is 1 divided by the total ionized plus unionized. So you get 1 over 11. And then if I do 1 divided by 11 times 100, I'll get around 10%, just like in the last problem. Which is interesting because in the last problem, we had a different formula, right? In the last problem, we did the ionized over the unionized. and we got 10%. And in this problem, we did the unionized over the ionized, and we got 10%. But that just has to do with what you're starting with and how to set up your formulas. So if you're not sure, you can always check it conceptually, which is what I like to do. So I know that I have a UB, and I have a pH that is actually greater than my pKa. pH is 7, the pKa is around 6. And so I have a base that is in a basic environment. So because that base is in a basic environment, it's going to stay primarily in its unionized form, right? And when I solved my percentage, I was getting the percent ionized, and the percent ionized was only 10%. So that confirms that the other 90% is the unionized portion. It is the portion that I predicted would be the majority. Like I already predicted that I would get predominantly unionized. Mathematically, I only got 10% ionized, and so that confirms how you would solve this problem conceptually. So I highly recommend don't just do the math and move on to the next question. Take a step back. It only takes a couple seconds to answer the question conceptually to make sure that you actually did your math correctly and you didn't accidentally flip anything. All right, so now just for fun, we have a neurotransmitter here, GABA, and GABA is actually synthesized in the brain from glutamate. And what I want to know is, what does GABA readily cross the blood-brain barrier? So in order to understand that, you kind of need some background knowledge. So to cross the blood-brain barrier, you actually need the uncharged hydrophobic form, right? So if a chemical structure, a drug, is primarily in its unionized form or is hydrophobic, it will more readily cross the blood-brain barrier. So go ahead and just to wrap up this video, see if you can determine what form and what charge GABA would be at physiological pH of 7. So is it going to be primarily unionized or ionized, and then what charges would you have, and do you think, based on that information, it will cross the blood-brain barrier? In the next video, I'll go over the answer to this question.